Hello, chemistry student. I'll be going quite fast through this, so if at any point you need to something review it, just go ahead and go back and replay the part, okay? The reason why I'm going fast is because YouTube limited me to 15 minutes, and so if you have any question, feel free to email me and ask me a question during the sync meet on Thursday and Friday. In chemistry, there's an important law called the law of conservation of mass that tells you that the total mass going in a reaction is equal to the mass going out. Basically, whatever number of atoms going in is equal to the atom going out. And you can tell that there's a chemical reaction, usually when there's a change of smell, a gas that's new being created, light and heat energy being produced, or when you mix liquid together, you get a solid being created that's called precipitate. So what goes into the chemical reaction is called the reactant. It is before the arrow, and where the arrow is pointing to is what is coming out, that's being created, that's called the product. Chemical equation represent a chemical reaction in real life, just like a recipe usually represent cooking a dish or, making a product. So here's an example of a chemical equation, very, very straightforward. And you see combustion of natural gas reacted with oxygen to produce or to make, and this is the arrow we're talking about, carbon dioxide gas and water vapor. And when that happens, light is produced as well as a change in smell and so on. Another way to represent an equation in a longer way, which rarely ever used, is called Wood equation, like saying what I said verbally earlier, natural gas reacting with oxygen, making water and carbon dioxide, instead of the formula. A skeleton equation is just an equation representing the ingredient involved in the reaction, but not balanced yet. That means you don't know the total number of atoms going in and out is equal to each other or not. Along with that, you will also see state symbol in an equation. G is gas, L is liquid, S is solid, and AQ represent anything that's dissolved in the liquid afterward. So skeleton equation, not balanced. So to balance the equation, make sure you remember that you only can add coefficient on the front of a element or a compound. So we cannot use anything else except only coefficient in front. And that coefficient is multiplied by the whole particle afterward. You stop when there's a plus sign or a equal sign, but only the particle that's right after the coefficient. And coefficient always have to be a whole number. If you happen to end up with an equation that's like 636, you have to reduce it down to the lowest ratio. So 636 would be 2, 1, 2. So here's just the basic rule, and I'm going to go over it, and you can learn it from me doing the example directly. So here I have a balanced equation. It's only balanced because originally I only have 2O, and I have 2 plus 1, which is 3O. So to get the O to be equal, I often change the odd number into an even number. So I have a 1O right here. By adding a 2, that makes it 2O plus 2O to change it to 4. Now, how do I get this 2O to be equal to 4? I add another 2 over here to multiply it by that. And that changes the O to 4. And the C and H is already equal. That's now it's balanced. Obviously, best way to learn is to watch. So I'm going to do this one quickly. So the first step for me usually is I list all the elements involved. And whatever I list on the left side, I list on the right side. I don't have to bother thinking. I just make sure I list the list on the left side and then copy it over. On the left side, I have 1 C. And I have 2O. On the right side, I have 1 of each. So obviously it's not balanced, so I have to balance the O. And only coefficient is allowed. So the only thing I can add is a 2 here. But when I do that, it's multiplied by the whole thing afterward. So now I have 2 of each. But now my C is not balanced, so I'll balance my C last by putting a 2 there. And that changes to a 2. Once all the number on both sides are equal to each other, and you see this the lowest possible ratio, when you don't see any number, that's 1, and 1 is the lowest thing you can get, you have it balanced already. Just a hint, you notice I balance the C last. I often leave the single element for last in an equation. Here I have both O and C, so it doesn't really matter which one, but you see that in a later equation. Some equation in life is already balanced, so you don't have to balance them. Here's an example. I list Ca, I list O, I list H, and then O again, so there's no point in me listing O twice, and whatever goes in must come out. And I count both sides really quickly. I have 1 Ca on the left, I have 2O, and I have 2H. On the right, I have 1CA, I have 2O because that O is multiplied by the 2 on the outside, and I also have 2H. Since the number is already equal, there's an example of an equation that's already balanced. So this synthesis equation, where things combine to make one product, is balanced array. Not all synthesis equations are balanced. This is just one random one that happened to work. Here I have a slightly more complex equation, but it actually doesn't take that much more time. I see this polyatomic ion called NO3 going in and NO3 going out. You can either count that as a single element of N and O, or you can count it as an NO3 particle. Because it's coming out as the same particle, you're allowed to do that. So here I will list all the elements involved, going from left to right. You can list it in a special way. Some video on YouTube shows you that. I don't bother thinking about that too much. And whatever goes in must come out. And now we count. So here I have 2Al on the left, 3S, 1Ba, and then the NO3 is multiplied by 2, so there's 2 of those. On the right, I have 1Al, because there's no number next to Al. S, I only have 1. Ba, I have 1. And then NO3 is multiplied by 3, so I have 3. I often do the polyatomic ion first to just get it out of the way, because when you balance it at the end, it can mess everything else up. So I have 2 and 3. What's the lowest common number between 2 and 3? It is 6. So how do I get both of them to become 6? I take 2 on the left side and then multiply by 3. 3 times 2 makes 6. And then 3 over here, I multiply by 2, making 6. After that, I can go and balance anything else. So I see BA is the same, S is not the same, and AL is not the same, so I might as well just take care of AL or S. It doesn't really matter which one. Let's just go with AL because it's the very first one I see on my list. I have 2AL on the left, but when I put a 2 here earlier, that updated my AL already. So wow, by taking care of the NO3, I didn't have to do anything for the AL afterward. Now I have 3S on the left side, and now when I did a 3 over here also, that changes that to 3. So I have both BA and S I need to update, and since they're both 1 on the right side, all I have to do is put a 3 right here, and that multiplied by the whole thing, changing both the BA and the S to 3. Here's a simple one of Na and Cl. Once again, I make my list, and whatever's on the left, I do on the right. On the left, I have 1 Na and 2 Cl. On the right, I have 1 of each. So I take care of the 1 by changing it to 2. So the Cl is the 1. I put a 2 there. Once I do that, that changes both of my Na and Cl to 2. So now I do my Na last over here by putting a 2. So you notice the whole time, the only number I can put is a whole number on the front. Sometimes you can get away with a decimal, but once you finish with that decimal, multiply it by the bottom number in the fraction that that decimal represents. So for example, if I have a 0.5 that represents 1/2, I would multiply all the coefficient by 2 to get rid of a decimal, because the rule is I have to have a whole number. This is a combustion reaction. I know it's a combustion reaction because I have some kind of fuel that has either carbon and hydrogen, or carbon, hydrogen, and oxygen. And when I do my balance equation, the 3 letters involved when I list it is CH and O, CHO. So here I have 2, I have 4, and I have 2. On the right, I have 1. H, I have 2. And then O, be very careful with O. I have 2, and I have 1 right here. That makes it 3. A lot of people who don't count that carefully will get that wrong. So here, I see that O is a single element. I will save that for last. So I will balance the C and the H first. I have 2C on the left. I have 1 on the right. So by putting a 2 here, that changes my C to 2. Obviously, that also multiplied by the O, so I'll cross that out for now, and I'll get back to O later. H, I have 4 on the left side, and I have 2 on the right side, so I also put a 2 over here. And that changes that to 4. Sorry, 4. And what did that do? That also changes my O. So now, quickly count all my O's again. And I have 2 times 2, which is 4O. From this one, and I have 2 times 1, which is 2O, for a total of 6O. And how do I get 2 to become 6 on the left side? I simply multiply it by 3, and that becomes 6. So that's how you do that balance equation. So for the homework today, you have 6 questions in dark red, starting with this one for you to do. Do them as best as you can. If you need help and need more practice, please come to the Sing Meet on Thursday and Friday. I'll be going over every one of these to help you, along with identification of what type of reaction they are. So these are one that you would do for your homework. With that, good luck. And if you have extra time and skill, go ahead and try to balance this one for extra practice if you want to.